Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in checking if two trees are mirrors of each other. First, let us understand what exactly mirror of a binary tree means. Mirror of a binary tree T is another binary tree with left and right children of all non-leaf nodes interchanged. Now, let us see the algorithm which will assist us in finding out whether two trees are mirrors of each other or not. Let us also have a sample trees to test our algorithm. We will be using two stacks for this. We pass the root nodes of both the trees into root 1 and root 2. Since both the trees has root equal to 1, so root 1 and root 2 both will point to 1. Now we enter the outer while loop and we perform the iterative in-order traversal of first tree and reverse in-order traversal of second tree. Since both are not null, we enter the inner while loop. Now we compare the data of both roots. Since it is equal, we push root 1 into stack 1 and root 2 into stack 2. In the next step, we reinitialize root 1 to root 1's left and root 2 to root 2's right. So root 1 will now point to 3. Also, root 2 will point to 3. Again, since both roots are not null, we continue with the inner while loop. Next, we compare data for both roots. As they are equal, we push root 1 and root 2 into stack 1 and stack 2 respectively. Now, we make root 1 point to root 1's left, so root 1 will point to null. Also, root 2 will point to root 2's right, so root 2 will also point to null. We check if root 1 and root 2 are not null. Since it is false, we come out of the inner while loop. Now we check if at any point one root becomes null and the other root is not null. Since it is false, we now check if both the stacks are not empty. As this is true, we now assign root 1 to the top element of stack 1 and root 2 to the top element of stack 2. So, root 1 and root 2 both will point to 3. Next, we pop the top element from stack 1. So, 3 is popped. Then, we pop the top element from stack 2. So, 3 is popped from stack 2. Now, root 1 will point to root 1's right. So, root 1 will point to null. Also, root 2 will point to root 2's left. As it is null, root 2 will also point to null. Now we check if both roots are not null in the inner while loop. Since it is false, we check if both stacks are not empty. As both are not empty, we assign root 1 to top element from stack 1 and root 2 to top element from stack 2. So, root 1 will point to 1 and root 2 will also point to 1. In the next step, we pop the elements from stack 1 and stack 2. So, 1 will. Now, we make root 1 point to root 1's right. So, root 1 will point to 2, which is the right child of 1. Also, root 2 will point to the left child of 1, which is 2 in tree 2. We continue with the inner while loop. Since both roots are not null, we enter the inner while loop. We check if the data of both roots is not equal. Since it is false, we push root 1 into stack 1 and root 2 into stack 2. So, 2 will be pushed in both stack 1 and stack 2. Now, we make root 1 to point to root 1's left. So root 1 will now point to 2's left, which is 5 in tree 1. Also, we make root 2 point to root 2's right. So root 2 will point to 5, which is the right child of node 2 in tree 2. Since root 1 and root 2 are not null, we continue with the while loop and compare data of both roots. As it is equal, we push root 1 and root 2 into stack 1 and stack 2 respectively. So 5 is pushed into both stacks. Now we make root 1 point to root 1's right. Since 2's right is 4 in tree 1, root 1 will point to 4. Also, we make root 2 point to root 2's left. So root 2 will point to 4, which is the left child of node 2 in tree 2. Since both roots are not null, we continue with the while loop. Again, we compare data for both roots. Since it is equal, we push both roots into stack 1 and stack 2. So we push 4 in both stacks. Also, we make root 1 point to root 1's left. Since 4 does not have any child, it will point to null. The same goes for root 2. So root 2 will also point to null. As both are pointing to null, we come out of the inner while loop. We check if one root is null and other is not. As it is false, we check if both stacks are not empty. As both stacks are not empty, we make root 1 point to stack 1's top. So root 1 will point to 4. Also, root 2 will point to stack 2's top. So root 2 will point to 4. In the next step, we pop 4 from both the stacks. We assign root 1 to root 1's right. Since 4 does not have a right child in tree 1, root 1 will point to null. Also, root 2 will point to root 2's left. So root 2 will point to 4's left child in tree 2, which is also null. We check if both roots are not null. Since it is false, we check if both stacks are not empty. As both stacks are not empty, we make root 1 point to stack 1's top and root 2 point to stack 2's top. So root 1 and root 2 both will point to 5. Then we pop the top element from stack 1 and stack 2. So 5 is popped from both the stacks. We make root 1 point to root 1's right and root 2 point to root 2's left. Since 5 is a leaf node in both the trees, root 1 and root 2 both will point to null. As they are pointing to null, we move on to the if statement and check if both stacks are not empty. Since both the stacks are not empty, we make root 1 and root 2 point to the top element of stack 1 and stack 2. So both root 1 and root 2 will point to 2. Now we 2 from both the stacks. Again, we make root 1 point to root 1's right and root 2 point to root 2's left. So root 1 and root 2 will both point to 4. Since root 1 and root 2 are not null, we continue with the inner while loop. We compare the data of root 1 and root 2. Since both are equal, we push 4 into both the stacks. We make root 1 point to root 1's left and root 2 point to root 2's right. Since 4 is a leaf node, both the roots will point to null. Since both roots are null, we come out of the while loop. Now we check if both the stacks are not empty. Since we have one element, we make root 1 and root 2 point to the top element of both the stacks. So both root 1 and root 2 will point to 4. Then we pop 4 from both the stacks. we make root 1 point to root 1's right and root 2 point to root 2's left. Since 4 is a leaf node, both root 1 and root 2 will point to null. We check if root 1 and root 2 are not null. Since it is not, we check if both the stacks are empty. As both the stacks are empty, we go to the else part and break. Finally, we return yes as both the trees are mirrors of each other. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.